Understand chemical kinetics and reaction order. The order of a reaction cannot be determined simply by looking at the stoichiometric coefficients of a balanced overall chemical equation. Instead, it must be determined experimentally by analyzing how the concentration of the reactant changes over time. Recall the graphical representations of integrated rate laws. First-order reaction. The integrated rate law is mathematically represented as ln A ln A0 equals kT, therefore ln A T equals kT plus ln A0. This equation matches the equation of a straight line, y equals mx plus b, where y equals ln A, x equals t, and the slope, m, is equal to k. Therefore, a plot of ln H2O2 versus time will yield a straight line if the reaction is first order. Second order reaction. The integrated rate law is 1 over AT. 1 over A0 equals KT, therefore 1 over A equals KT plus 1 over A0. This also matches the equation of a straight line, but with y equals 1 over A. Therefore, a plot of 1 over H2O2 versus time will yield a straight line if the reaction is second order. Zero-order reaction. A plot of the concentration H2O2 versus time will yield a straight line. Identify the correct experimental test. To determine if the decomposition of hydrogen peroxide is first order, a student would plot ln H2O2 versus time. If this plot is linear, it mathematically confirms first-order kinetics. This directly matches the statement in option B. The correct answer is option B. The reaction is first order if the plot of ln H2O2 versus time is a straight line.